Assalamu alaikum and hi for everyone. I am Ismail Taha Ahmed from Iraq. Today I'm talking about our paper title Image Copy Move Forgery Detection based on Special Feature Domain. Firstly, I'm talking about a brief introduction. What is image forgery? The manipulation may be either by add or delete or alter any the properties of an image without take any hint for this change. Therefore, digital image forgery is very active research field. DIF can be divided to two groups. First one is active DIF. This one is depend on original image, on info from original image, and second one is passive without depend on any info from the original image. You can see this photo. The first one is original image. The second one is forgery or forget image. You can see this one, the tiger here. This one is forgery. The properties of this image is very changed because add something here. Copy move forgery is common kind of method of image forgery detection. This one using copy or paste from one area to another area in same image. You can see this image. This one is the original image. Here the forget image, the copy move forget image. You can see here this one is add from this one, like this one same, but wrap it inside this one. So this one original image, here the forget image. There are several copy move detection techniques based on transform domain like DCT, wavelet, curvelet, radiuslet. So the existing algorithm have some limitation and suffer from the drawback such as the high computational complexity, the first one, and second one, some of them not robust to some of post-processing operation like blur and lossy and combination of this operation. Our proposed method depends on 5 steps. The first one, the image pre-processing by convert the color image, the RGB image, to grayscale image. Second one, divide the image into non-overlapping blocks under various block size. And third one, for each of these blocks, compute the statistical feature like mean and standard deviation. After that, to increase the speed of matching the blocks, you can see by using the sorting of this feature. Finally, here the final feature vector sorted can feeding to SVM classifier to identify the image, the original or forget image. After propose our method, in order to verify and evaluate our proposed method, we use the public data set, like name is MICCF220 database. This one is focused only on copy move forget images. For details of this database, you can see the name and the total image is 220, the original image 110 and forget 110, and the image format JPG, resolution varies from 722 until 800 multiply 600. Attack kind only 2 operation is rotation and scaling. After select this copy move images, can use the sum measure to performance evaluation like accuracy detection by using these equations. The correctly detection copy move divide actually copy move must multiply 100% can produce the detection accuracy. The SVM classifier used for cross validation is 10-fold for training and testing. So we divide the image selected from this database, from this public database, into training dataset and testing dataset by 10-fold cross validation. Proposed performance evaluation. The performance was compared in terms of detection accuracy versus block size. You can see this table here, block size 32 multiply 32 and 64 multiply 64 and 100 28, 128. This one is various block size, so they produce the detection accuracy here 96 here, 98 here, 97. You can see when increase the block size, something is increased in detection accuracy. So for this figure you can see that from 32 and 32 is increased like here, like in 64 multiple 64, and drop very little for 128 for block size. So from this result you can select the block size is 64 multiple 64, because here there's a drop the result but very small, so we are select 64 multiple 64 for block size. All of this detection accuracy, this one is applied on database is MICC F220. So the final and the super result is 2844 for this block size. So in our proposed algorithm we select the block size is 64 multiply 64 for block size, and the final detection accuracy is 9844. Here we compare them our proposed with the previous image cover move feature detection works. We select some of them, but we select them very recently work proposed for period 2015-2020 until 2020. This one is depend on different domain. Like example, a special domain here, special domain without use any transform, but here would use the transform domain after convert the image from special domain into transform domain. As mentioned before, the transform domain take time because convert from domain to another domain. This table you can see here the techniques. This one techniques here, different special domain and transform. The years from 2015 until our proposed 2021, and domains is different, special and transform domain. Method here you can use the different method and feature here because use the special domain and transform domain, and last column is detection accuracy here. The 2025 you can see this one is India, this one is 92, but the special domain here, special domain until here this one is a special domain. And after that transform you can see here our technique is high accuracy and without domain transform, but here you can see this one is bold color. You can see this one is Rahul in 2017 use transform domain, but the detection accuracy is very high, however use the transform. So this one is limitation of this method because take time computing and take time for computational complexity. So but here the proposed method shows the maximum accuracy around 9844 compared with other techniques based on special domain, and the transform domain is very high. You can see here the Rahul is very near accuracy to our proposed, but they use transform domain take time, but ours without use any transform, just use special domain for whole image, no need to take extra time for convert, so ours is very high and better than other domains. In terms of detection accuracy, below the figure you can see the performance was compared from DIA until our proposed. The proposed method shows the maximum accuracy compared to other current techniques based on special domain. So this one is ours and near with transform domain here, but ours is very better because especially special domain. Conclusion: the proposed contained on 5 steps image preprocessing, dividing the image into overlapping blocks, determine the statistical feature like mean and the standard deviation of each block, sorting the feature into matrix, and finally feeding the feature vector sorted to SVM classifier to classify the image as original or forget image. Our experimental findings show that the Kaboom Forgery can successfully detection by proposed ICMFDS with high accuracy is 98.44%. We compared the result of our proposed with many current CMFD method from 2015 until 2020. The findings revealed that our proposed proceeding higher outcomes than others. So for in future work, we plan to expand the application of our proposed in feature to recognize other kind of image forgeries like splicing image forgery. Thank you.